Okay, let's write some vectors in component form. So remember, to know everything about a vector, you need to know two pieces of information. Either its x and y components, or you might know its angle, its direction, and its magnitude. Here we're given the direction and the magnitude. Our vector is 10 degrees rotated from counterclockwise from the x-axis, and our magnitude is 7. I want to write this vector as some vx comma vy. So I'm going to draw out my triangle. It's a trig class. Always draw out your triangle. Over here, hypotenuse is the magnitude, and it's always positive. This side is 7. I want to know this y component and this x component of this triangle. It's just using trig. This is literally what we've been taking trig for all semester, is to solve this problem. Really just solving a triangle. So I like to use sine. I would write out here sine of 10 degrees is opposite over hypotenuse. So then multiplying over Vy will be 7 times sine of 10 degrees. And we'll just type that in our calculator. And we get 1.216. And we weren't given units. We don't have to write units on there. Same thing for the other one. Now we know if y came out to be a sine, the x is going to be a cosine. But let's check it. What is cosine of 10 degrees in this triangle? Adjacent over hypotenuse. So Vx will be 7 times cosine of 10 degrees. Let's type that in a calculator. And we get 6.89. So our vector in component form, vector v, will be, remember to always use the angle brackets here, not parentheses, will be 1.216, approximately 6.89. Okay, let's do a harder one. Let's do one in quadrant 2. So let's say we know that this is a 70-degree angle, and let's say our magnitude is 10. And let's throw some units on here, 10 meters. Okay, we're going to draw our triangle. Here's my x component. Here's my y component. Magnitude is the hypotenuse, and it's always positive. Now, if you want to memorize formulas, you can memorize. These formulas are true. The x component will always be the magnitude of v times the cosine of theta. Vy will always be magnitude of v sine of theta. But these formulas only apply. These formulas only work if theta is this angle. The angle from the positive x-axis. So if I want to go through the trouble of finding that angle, it's plug and chug. Memorize the formulas, you'll get the right answer every single time. It would work, and maybe we'll try it here. That angle here would be 120 degrees. So Vx, I guarantee you, type this in your calculator, will be 10 times cosine of 110 degrees. 180 minus 70. Vy is 10 sine of 110 degrees. Now, I know I'm likely to goof finding that angle. I just did. I said 120 instead of 110. So I'm not going to do it that way. I'm going to use the triangle I have. I'm going to look at this triangle and just use trig. That's more trustworthy to me. So forget about these formulas. Use the triangle I have. Look opposite the 70 is Vy. So Vy will be 10 times sine of 70 degrees. I'm using a reference triangle here. Vx will be 10 cosine of 70. Oh, but there's a problem. If you do it this way, look at that x. That x is clearly negative. Over here, type that in. The negative pops out for me. I don't have to worry about it. I just had to go through the trouble of finding this angle. If I do it this way, the negative doesn't pop out for me. I have to find the negative. I have to see it and go, oh, that's a negative, and put it in myself. So you just got to be a little careful there. And then we type both of those in our calculator, and we get these numbers. Try this on your own. Vy, 10 sine 70, 9.4. Vx, I do 10 cosine of 70. That gives me 3.4. I have to put in the negative myself. Then that vector v is the vector negative 3.4 comma 9.4. Make sure you use angle brackets here and not parentheses. It's not a point, it's a vector. How could we check this? We could do Pythagorean to see if we get a magnitude of 10. We could do an inverse tangent, y over x, and see if we get a 70-degree angle. Okay, let's do another one, but this time we're going to be given the wrong angle. And we could either stress about it and memorize formulas, or we could just use the trig that we know. Let's say we're told that angle right there is 28 degrees. And let's call this guy W. Let's say his magnitude is 5. So if I want to use those formulas I just wrote out, this would still be true. The x component is magnitude cosine of theta. The y component is the magnitude times sine of theta. But that only works if I'm measuring this angle, which is not 28 degrees. So I could go through the trouble of finding that angle. It's really not bad. Or I could just use the trig knowledge that I have. This is 28 degrees here. Magnitude is the hypotenuse, and it's always positive. This side is 5. This is my right triangle, and I just look at the picture. Over here, this is an x component. It goes in the x direction. This is a y component. Now I just use my picture and my knowledge of trig to figure out which one goes with sine and which one goes with cosine. So from this 28 degrees, across from the 28 is x. So Wx will be 5 sine of 28, and Wy will be 5 cosine of 28. That's in this right triangle. And then I just type those in. And typing those in the calculator, I get these values. 2.35, 4.41. We would get exactly the same thing if we used this angle, which is, what is that, 62 degrees. And we use these formulas. It would still give us exactly the same thing. Then my vector W in component form is the x, 2.35. These, of course, are approximate, 4.41.